Section 5.1 is dealing with multiplying polynomials. So this is the introduction to Chapter 5. The first thing I'm going to go through is how to use algebra tiles, because they will be on your provincial exam, and they're also in your book a bit, and there are a few questions based on them. So, using algebra tiles, you have to kind of understand what is being asked here. The first thing on the outside is I'm going to show you what these two things represent. Notice I have a green, and then I have, these are supposed to be white, and this one down here is red. So with algebra tiles, you have two things. You have positive tiles, negative tiles. You also have another two things. You have X tiles, and you have 1 tiles. This is what is called a positive X tile. These are positive X tiles. Positive X tiles. These are negative 1 tiles. If it's red, it's a positive 1 tile. On the provincial exam, they color them differently, and you'll have to know, and I'll explain that in, I think, Chapter 5.3. So in this one, for now, we'll just leave it like this, keep it simple. What I have on top is I have an X tile, and I have 1, 2, 3 negative 1 tiles, so that's minus 3. On the side here, I have 2 X tiles, and then I also have a plus 1 tile. So that when I'm multiplying these two things together, which is what is being shown here, I'm going to have to fill in the area inside. So what I do is I draw a side length that's equal to the side length there. Then I draw a side length that's equal to the side length of there. And I complete drawing my square. Again, I draw a side length that's equal to the side length of that one, and I draw a side length that's equal to the one above, and I complete another square. Next thing I do is I draw a side length that's equal to that little one there, and then I also draw a side length that's equal to the one above. Similarly, now these ones I'm going to have to color white because they're negative tiles. So I draw a side length that is equal to the side length of this one here, and a side length that's equal to that little one there. So I get these rectangles. Rectangle, rectangle. And similarly, I get a rectangle because I'm drawing the side length that's equal to that one, and a side length here that's equal to the one above. And then finally, I have a side length here that's going to be equal to the one above. Now notice that these are all going to be negative tiles because I have a negative 1 times a negative, or times a positive 1. So side length equal to that one, side length equal to that one. So these are going to be little tiles. Now I just have to figure out what is being asked here. So I have an x squared tile and an x squared tile. I also have a positive X tile here, but I have a negative X tile, whoops, negative X here, negative X there, and then these are all negative 1 tiles, negative 1, negative 1. So if I have a positive X tile here, it's going to cancel out with one of the negative X tiles there. So I can kind of think about this as being crossed out with one of those ones there. And then you have to figure out, well, what am I left with on the inside? I'm left with 2 x squared tiles, and then I'm also left with 1, 2, 3, 4, 5 negative x tiles, so negative 5 x tiles, and then 1, 2, 3 minus 3 tiles inside. How does that correspond to what I had above? So I've done it with the picture. I'm pretty sure I'm right, but I would like to check myself. So let's check here. I have x minus 3 times 2x plus 1. So in order to finish this off, I have to do what's called the distributive property. So I would multiply the first with the first one, the two outside ones, so the first ones, the outside ones. Then I would multiply the inside ones, I. Then I would multiply the last two, L. It's this little thing called FOIL, F-O-I-L. The first two, the outside two, the inside two, and the last two. And that's kind of how I work these. So when I'm multiplying these out, I get x times 2x, which is 2x squared. Be very careful with that. It's not 3x. I'm not adding these. I'm multiplying. Then I have x times plus 1. So I have a plus x. Next thing I have is on the inside I have a negative 3 times a 2, which is a negative 6x. And finally on the outside I have a negative 3 times a 1, which is a negative 3. So if I combine like terms here, I have an x term here, a plus 1x, and a minus 6x. So I end up getting 2x squared minus 5x, because plus 1 minus 6 is negative 5, minus 3. Notice I get the exact same answer. It's just this is a pictorial form, like a picture, and this is an algebraic way of doing it. Let's keep going and see how this works. So we've just done the distributive property. Let's do it again. Here's an x minus 3 times x plus 8y. Remember how to do FOIL. You're going to be multiplying 4 things together. So these two, then the outside, then the inside, then the last. So x times x is x squared, not 2x squared. I'm just multiplying x times x, so I have to add the exponents. Next I have x times 8, which is plus 8xy, x times 8y. So notice that the two exponents go next to each other. I can't add the exponents because they're different variables. Next thing I have is a negative 3 times x, so I have negative 3xy. Notice I didn't put yx. I want to put them in order all the time so I can see what like terms I have. And lastly, I have negative 3 times 8, which is negative 24. And I also have the y times the y, which is going to be y squared. The only two like terms I have are 8xy and negative 3xy. So this breaks down or simplifies into x squared plus 8 minus 3 is plus 5xy. And then finally minus 24y squared. And that's my final answer. Let's keep going here. Uh-oh, now I have 2 terms but 3 terms. Oh, this is going to take a long time. Well, we'll keep going. Now, FOIL doesn't really work here, but the idea stays the same. I have to multiply the first ones, then the first by the second, then the first by the last. Then I will multiply all the inside terms. So let's work with those ones first. X times 2x squared is 2x cubed. I'm multiplying the x that has an exponent of 1 with the x that has an exponent of 2. Add the exponents, it becomes x cubed. Next I have x times negative 3x. So I have negative 3x squared. Next I have x times 1, which is just plus 1x. You don't need to put the 1. So I'm done with the first one. Now let's go to the second one. The 2 times all the stuff in the second set of brackets. So 2 times 2 is 4 plus 4, x squared. 2 times negative 3 is negative 6, and I just have an x there. And then 2 times 1 is plus 2. Now I have to look at like terms that I have. Do I have another x cubed? No. Do I have another x squared? Yes, right here. So I have this one here and that one there. Do I have another x? Yes. So I have this one here and this one here. And the 2 is on its own. So finally, my 2x cubed is the only one that's like 2x cubed. I have negative 3x squared plus 4x squared. So I actually have plus 1x squared. Notice I'm not putting the 1. And then I have plus 1x minus 6x, which is negative 5x. And then I finally, at the end, I have a plus 2. Now I shouldn't have any like terms because I've already combined them all. All right, let's keep going here. A couple more examples and then I'll finish off. Simplify. Notice that I have a plus sign in between. So I'm going to have to FOIL this. I'm going to have to FOIL this. Actually, a little bit more than that. And then do the addition at the end. So let's work with this here. First thing we can do is multiply the first set of brackets out. So I have x times 3x, which is 3x squared. X times negative 2 is minus 2x. Then I have the inside, 1 times 3x and 1 times negative 2. So I get 1 times 3x is plus 3x. 1 times negative 2 is minus 2. Now I'm going to combine some like terms that I have before I go on, just because I like to do that. Then I have 3x squared minus 2x plus 3x is plus 1x minus 2. Then I have a plus sign. Then notice I have to multiply the 2 in first. I could FOIL this out and then multiply by 2, but I'm going to multiply the 2 in first. So I'm going to do it a couple of steps here. So I have my plus sign. Then in brackets I'm going to have 2 times 2 is 4x. 2 times negative 1 is minus 2. And I still have the 5x plus 2. Now I can go ahead and do all my FOILing like I did before. So 4 times 5 is 20x. I'm going to put brackets here just because I have a plus sign and I have a whole bunch of stuff being multiplied. So 4x times 5x is 20x squared. Sorry, the x times the x is x squared. 4x times 2 is plus 8x. Then I do the outside, or sorry, the inside, and then the last terms. So the inside, negative 2 times 5 is negative 10x. And negative 2 times 2 is a minus, because negative times a positive is a minus 4. Check for like terms. I have an 8x and then negative 10x. So finally I can go 3x squared plus x minus 2 plus, now I'm going to get rid of the brackets because it's a plus sign. Nothing is going to change inside. It's just going to be adding everything. It's not multiplying, it's adding. So I have plus 20x squared, and 8x minus 10x is minus 2x, and finally minus 4. Now I look for, again, any like terms. Do I have an x squared term? Yes. Do I have an x term? Yes. Do I have another single term on its own? Yes. So 3x squared plus 20x, it's a plus sign, is 23x squared. I have a positive x, or just x minus 2x, so that's going to be minus 1x. And then negative 2 minus 4. Negative 2 minus 4 is negative 6. And that's your final answer. Be careful. It's very, very common to make mistakes when you're adding and subtracting negatives. All right. Last example here, and then I'll give you a little hint for the exam. So here I have one term multiplied by 1, 2, 3 terms. This one's not too bad. 2x times 4x squared. Well, I got to multiply the 2 and the 4 to get 8. I have to multiply the x and the x squared to get x cubed. Don't forget the numbers and the letters. Next I have 2 times negative 8, which is negative 16. X times x is just x squared. And lastly I have 2 times 17, which is 34. And then I have an x, no x there, so just an x tacked on. And that's it for that one. Just a simple example to show you how it works. Lastly, the your turn. Your turn, you're given this ramp for one of the questions, I can't remember which one, and you're asked to find the area if x is cut out. I'm not actually asked to find any of this part over here. None of this really matters. I'm not dealing with that. I'm just dealing with the top ramp part. Just the area of it. So for the area, I know it's 8 feet, but what's being cut out of it? This little part here, right? Which is a value of x. So I'm going to be having 8 minus x, and the bottom is 4, but again, I'm having this little part here cut off the end, kind of like this. It's going to be chopped off the end, and this here is going to be chopped off the end, so I'm losing this whole area here, which has a length and width of x. And then I'm going to have 4, and again, 4 minus that x part. And you should be able to multiply that out based on what we've just done and come up with an expression.